Hello everyone, and welcome to this lecture on numerical integration using Python. In this lecture, we'll explore how to perform integration on both data and functions using powerful Python libraries such as NumPy and SciPy. We'll start by looking at the numerical integration of data using methods like the trapezoid rule and Simpson's rule. Then we'll move on to integrating functions using quadrature techniques. We will then cover some applications, including the estimation of volumes for various shapes and solving a diffusion problem. Finally, we'll wrap up with a review of the key points. Let's start with numerical integration of data. Often we have data points representing a function, but not its analytical form. A classical way to approximate the area under the curve is using the trapezoid rule. We'll see how to implement this using NumPy and explore its accuracy. The trapezoid method is relatively straightforward. But for better accuracy, particularly for nonlinear functions, Simpson's rule provides a more refined approximation. We'll cover this method too, and again, we'll use the SciPy library to make it easier. Now let's move on to integrating functions. When we have the analytical form of the function, quadrature methods become very useful. Quadrature involves approximating the integral as a weighted sum of function values. In practice, we'll use SciPy's quad function, which is a highly optimized routine. This will handle even infinite integration limits. As for applications, we will consider how to estimate volumes, first of a simple sphere, and then we'll do a plug flow reactor example. Both of these illustrate how integration can be used to compute volumes given cross-sectional area, or a reaction rate as a function of conversion. Finally, we'll delve into an application related to diffusion, specifically using the error function to describe the concentration profile of a diffusing species in a semi-infinite solid. SciPy's special functions will make this calculation straightforward. To summarize, this lecture has covered numerical integration of data and functions. We looked at the trapezoid rule and Simpson's rule implemented using NumPy and SciPy's trapezoid, cumtraps, and simps functions. For functions, we used scipy-integrate.quad for efficient integration, even with infinite limits. Applications included volume calculations and solving a diffusion problem using SciPy's special functions. Remember to always consider potential errors in the approximations. This concludes our lecture. Thank you for your time and attention.